Hello, Mr. Choose here with Bear Algebra. Make sure if my algebra videos help you, give them a thumbs up, like them, share them, subscribe to my YouTube channel so that I can push it out to more people. So today we're going to talk about solving quadratics by completing the square if a equals 1. So if a equals 1, you're going to have a quadratic that looks like some number squared plus some number times that first power of that number that's squared plus some constant. All right, so first of all, you need an x squared plus bx plus c. So the ax squared are harder examples, so let's do the simpler ones in today's videos. So let's take example 1. And I'm just going to call it problem 1. And this is called lesson 9.04B. In problem 1, I have y squared plus 6y equals 16. So do I have a y squared plus by here? Yes. So if a is 1, I'm good. So a has to equal 1. And remember, this would be the basic form so this ends up being 1y squared plus 6y minus 16 equals 0. So I have that form. So I'm good to start. All right. Now, once I start, I'm going to write all the steps over here on the left, and I'm going to do them over here on the right. So, the first step, after you have a equals 1, is to have the value of b divided by 2. So, I need b over 2. So, my b in this case is 6. That's the number in front of the y to the first power. So that ends up being b over 2. And that can also be written as 1/2 b. So I have that here. So I'm just going to write that b equals 6. b over 2 would equal 3. So I need to find that particular number. Then on step 3, I need to take my b over 2 and square that. So, in this case, b over 2 squared would be 3 squared, which equals 9. Okay? So now what we're going to do is we're going to end up solving this and finding the roots of this. Okay, so the next step is to add b over 2 squared to both sides. All right? So I take this y squared plus 6y, and then I'm going to add 3 squared to the left, and I'm going to add 3 squared to the right. Okay? All right, my next step is to rewrite this as x plus b over 2 quantity squared. Now what am I rewriting? I'm rewriting this on the left. Now remember, we don't have x squares here. We've got y's squared here. So I have y plus the b over 2, which is 3, quantity squared, equals 16 plus 9 is 25. All right? So now you're saying, okay, but am I really sure these two equal? Well, use FOIL to find out. So I can take my y plus 3 times my y plus 3, use FOIL to see if they are equal. Y times y is y squared. Y times 3 is 3y. Y times 3 is 3y. 3 times 3 is 9. I have like terms here. So y squared plus 6y plus 9. Y squared plus 6y plus 9. That worked. Okay. So now I'm going to take the square root of the left and the square root of the right. And remember, when you take the square root, it's going to be a plus and a minus. So the square root of a square are inverses. So I have y plus 3 equals plus or minus 5. All right, so now I've got an equation I'm going to solve using inverse operations. So y is going to equal -3 plus or minus 5. So what does that mean? That means either y equals -3 plus 5 or y equals -3 minus 5. That's what it means. So y equals -3 plus 5 is 2, and y equals -3 minus 5, which is -8. So my two solutions are y equals 2 and y equals -8. Plug them in and see if that's true. 2 squared is 4, plus 2 times 6 is 12. 4 plus 12 is 16. That worked. -8 squared is 64, plus 8 times -8 is -48. 64 plus -48 is 16. But what does that mean graphically? That means that is the points on the x-axis where the graph of this quadratic crosses. Okay, so there was problem 1. Now problem 2 should be a little bit faster. So in problem 2, you can always pause it and see if you could figure it out. See if you did it right. We have y squared minus 8y minus 1 equals 8. Well, we have to have a equals 1, and we do. And remember, here would be my standard form. But I really want to have it equal some number, because I just need this out of here. Okay, so I'm going to add a 1 to both sides. And I have y squared minus 8y equals 9. So now remember, I'm trying to complete the square to solve this quadratic to find out what its roots are, which means the points that the graph crosses the x-axis. All right, so remember how we did this here. We're going to do b over 2, or 1/2 of b. So in this case, my b over 2, my b is -8. -8 over 2 equals -4. Don't know why I wrote -8. Now we're going to do b squared, b over 2 squared. So I'm going to take this number and square it. Negative 4 squared ends up being 16. Now I'm going to add this number to both sides. So now's where we come back to here now. So I've got y squared minus 8y plus, I've got my negative 4 squared equals 9 plus negative 4 squared. This is a perfect square trinomial. So I can take and rewrite it as x plus b over 2 squared. So I can rewrite this as y plus negative 4 quantity squared equals 9 plus 16. But these are always written plus the opposite as minus. Remember what we did here? We took the square root of this side, the square root of this side, and it's a plus and minus. So my solution is y minus 4 equals plus or minus 5. Because remember, the square root and the square are inverses. So I add a 4 to the left and add a 4 to the right, and that is using the addition property of equality is what that's called. And so I end up having as an answer y equals 4 plus or minus 5. Now I just have to do those. So the first possibility is y equals 4 plus 5, which is 9. And the second possibility is y equals 4 minus 5, which is negative 1. So I'm saying the roots of this quadratic using the completing the square method are y equals 9 and negative 1. So now, this should have followed along, and if you want to take this y plus negative 4, which is y minus 4 squared, and use FOIL, you're going to see that it ends up equaling y squared minus 8y plus 16. Check it out. That's what this one would be right here. This negative 4 squared would be plus 16. Use your FOIL to check it out. I did that in the first problem that we worked. All right, so now to check this, to see if this is true, 9 squared is 81, minus 72 minus 1 equals 8, and that works. Try negative 1 now. Negative 1 squared is 1, plus 8 is 9, minus 1 is 8, and they both worked. Okay, so I'm going to give you a couple challenge problems here that you'll be able to work, and then you can pause this video, and on the top link there will be a video that will work these out if you're watching on your device, and your device will show those links. Over on the top right, there will be a link to a video that is a Math Minute where I'm just talking about completing the squares that might be helpful. Down here on the bottom left will be a playlist, and over here will be another video or playlist. All right, so here they are, and I call these challenge problems 1A, and that's going to be in video, I'm going to call it 1C actually. It'll be in video L9.04C. So problem 1C is y squared minus 12y equals negative 20. And problem 2C is x squared minus 4x plus 4 equals 16. Now remember, you're going to have to subtract that 4 before you can complete the square. These are easy ones because a is 1. So remember, like my video, share it so that you can send it to other friends, subscribe to my channel, and keep watching my videos because I'm Mr. Chew. This is Bare Algebra, and I want to help you understand completing the square. We'll see you in the next video, remembering that you've got over here will be your link to the solution to these two problems, and over here will be a link to another example that might help it make sense. We'll see you soon. It's been a 16-minute video, but now it's done.